is everybody today?
Good.
Good. Get my books ready. Let's see.
My camera's not working for some reason. I don't know why.
I don't know. I know sometimes when I first started, it would be crazy because I could not figure out how in the world to make the camera work, and then sometimes it would work and sometimes it wouldn't, and I know it's such a hassle. All righty, so let's go ahead and take a look at where we left off last week. It's been a week since I've seen you. I hope y'all had a good break on Monday. Hope you enjoyed the day off. For some reason, it seems like at the end of a short week, I'm tireder than I am at the end of a long week. All righty, so let's see. So we were working on, we did greatest common factor and least common multiple, right? And that was lesson 16 and 17. Okay, so on, let's see, lesson 16 and 17, we had already done 15 with our divisibility tests. And then with lesson 16, let's see, that was page, so our homework on page 36, what page or what did we have for that? Was it activities 3 and 4? On page 36, okay, activities 3 and 4. And then we had page 38, activities 3 and 4, is that right? Okay. Alrighty, so we'll get ready and go over those homework answers from lesson 16 and 17. So let's take a look at those. All right, so on page 36, I'm gonna go ahead and pull up my pages real quick. Well, all righty. Okay, so it looks like we already did page 36. We already went over those. Does everybody have all those done? Everybody went over those? All righty. So then on lesson 17, it looks like we did activities 2 and our homework was activities 3. So let's go ahead and work through these. All righty, so in activities 3, we're using our order of operations, and remember that's going to be our PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. But the thing that we learned about that is that if I have Oh, hang on a second. I was trying to check my participants because we lost Olivia. Make sure I see when she tries to get
Jennifer texted me and she said that her internet's not working very well, so she got kicked out.
Oh, okay. All right, just text her back and tell her to keep that. I'll be watching for her to log back in so I can get her back in.
Okay, yes, ma'am.
Okay. All right, so we learned that we have to deal with our parentheses first. And so when we have parentheses, we have parentheses inside parentheses, we move into those and do those first. So our first thing is 4 plus 3. So I'm going to have 3 times 4 plus 3 is 7 to the 0 power plus 4 minus 1 divided by 2. Okay, so let's take a look at that. Now we're still working inside parentheses, and inside those parentheses I have an exponent. And so I've got 7 to the 0 power. What do I know that anything to the 0 power equals to? 1, right? So now we've got 3 times 1 plus 4 minus 1 divided by 2. Okay, so 3 times 1 is 3 plus 4 minus 1 divided by 2. So 3 plus 4 is 7. 7 minus 1 is 6. Divided by 2 is 3. Any questions on that one? Everybody do okay on that? Let's look at the next one. Again, I have parentheses inside of parentheses, so that's going to be where I start. So I have 2 times 3 divided by 7 minus 4 is 3. And then we have to the 3rd power. Still working inside those parentheses, and we can see I have multiplication and division. Okay? So what I'm going to do is I need to multiply first because I'm going to go in order from left to right. So I've got 2 times 3 is 6 divided by 3 to the 3rd power. 6 divided by 3 is 9. Whoop. To the 3rd power. Not 9, good grief, 3. 6 divided by, no, not 3 either. What am I doing? I need a nap. 6 divided by 3 is 2. And 2 cubed, 2 times 2 is 4. 4 times 2 is 8. Any questions on that one? All righty. Again, I have parentheses inside of parentheses, so I'm going to start working on that. One of the things that I can do, though, outside of my parentheses is I can go ahead and take care of these exponents also. So we'll go ahead and kind of work with that. We know 5 to the 0 is 1, 2 squared is 4, and 2 cubed is 8. So then we'll go in the parentheses, 3 squared, 3 times 3 is 9, minus 2 times 4 minus 3 divided by 2. All right, we've got still work within these parentheses, and I have subtraction and multiplication. So I know I need to multiply first. So I've got 1 plus 4 plus 8 times 9 minus 8 minus 3 divided by 2. Okay, we're going to keep on going. So inside those parentheses, I have 9 minus 8, so that's going to be 1. So I'm going to have 1 plus 4 plus 8 times 1 minus 3 in my parentheses and divide by 2. All righty. So what I'm going to have to do here is I see that I've got multiplication of 8 times 1, so that's just going to be 8. So I've got 1 plus 4 plus 8 minus 3 divided by 2. All right, so within those parentheses, I have addition and subtraction, so I'm going to work from left to right. 1 plus 4 is 5. 5 plus 8 is 13, and 13 minus 3 is 10. Divided by 2 is 5. Any questions on that one? Did I mess that one up somewhere? Oh, I guess it would help if I was looking at the right page. I was looking at different answers and I was going, something's wrong with that. That doesn't work. Yeah, so the answer on that one is 5. Any questions on that? All righty, so now our last one. Working inside our parentheses. So we're going to have 3 times, we're going to go ahead and take care of these exponents. 6 squared is 36 minus 5 squared is 25 minus 3 times 2 plus 10 divided by 2 plus 3 to the 0 in parentheses divided by 7 to the first. All right, so still working inside those parentheses, I have subtraction and multiplication. So I keep my 3 here. I'm going to multiply first. So I have 36 minus 25 minus 6 plus 10 divided by 2 plus 3 to the 0 divided by 7 to the first. Keep going inside those parentheses. 3 times 36 minus 25 is going to give me 11. And 11 minus 6 is 5. Plus 10 divided by 2 plus 3 to the 0 divided by 7 to the first. I'll write this over here so I can see it. So let's see. So when I was here, you can see I've got multiplication and I've got division, but I'm going to do it in order from left to right. So I'm going to start with that 3 times 5 is 15. So I'm going to have 15 plus 10 divided by 2 plus 3 to the 0 divided by 7 to the first. Now I'm going to divide 15 plus 5 plus 3 to the 0 divided by 7 to the first. All right, I've got to take care of that exponent. I should have taken care of that earlier. So I've got 15 plus 5 plus 3 to the 0 is going to be 1 divided by 7 to the first, which we'll go ahead and just do that as just 7. Go ahead and take care of that exponent. So now I'm going to add what's in my parentheses. 15 plus 5 is 20. 20 plus 1 is 21. Divided by 7 equals 3. Everybody get 3? Any questions on that? Okay. So then the rest of this, we were doing greatest common factor for each set of numbers. Okay, so what I'll do is I'll just go ahead and put the answers on here, and then if you have any that you missed and we need to work through them, let me know, okay? So what we'll do is we will go down the left side first. So the greatest common factor of 9 and 12 is 3. The greatest common factor of 15 and 18 is also 3. And the greatest common factor of 9, 12, and 24 is 3. Any questions on that column? Okay, let's look at the middle. My greatest common factor of 12 and 15, surprise, it's 3. My greatest common factor of 16 and 24, finally we get a different one. Greatest common factor is going to be 8. Greatest common factor of 12, 15, and 21, 3 again. Any questions in that column? Okay, and let's look at the last one. Last one's kind of hard to see. I'm dealing with 18 and 24 up here. Greatest common factor of 18 and 24 is 6. My greatest common factor of 20 and 25 is 5. And the greatest common factor of 16, 18, and 24 is 2. Any questions in that column? All right, good deal. So then we are going to go ahead and move on to lesson 18 today, dealing with square roots. Okay. All righty. So you know how we talked about exponents of numbers when we talk about a number squared. Okay. So let's think about this for just a minute. When I am dealing with a number squared, actually, let me get just a blank piece of paper for a minute and then. Okay. So if I'm talking about a number squared, like if I have 2 squared, we know that that's going to equal 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. These are all going to be perfect squares that are going to be helpful if you go ahead and just memorize them. 6 squared is 36. 7 squared is 49. 8 squared, 64. 9 squared, 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. And that's pretty much, as long as you know those are going to be some perfect squares that you're going to encounter between pre-algebra and algebra 1, especially in the Horizons book. There are going to be some other ones that you see too, but those are just the ones that it's going to be super helpful for you to memorize. And so you know how we've talked about opposite operations and things, like we know that addition and subtraction are opposite operations. Multiplication and division are opposite operations. Well, when we're dealing with squaring a number, that's going to be the opposite of taking the square root. Okay, so when I look at 2 squared equals 4, I can reverse that, and I know that 2 squared equals 4, so that means the square root of 4 equals 2. Okay, so when I'm taking the square root of a number, I can also break it into prime factorization. So what we're going to do is we're going to kind of look at that a little bit today, but the first thing I want to do is kind of break down each piece of this problem. Okay, so when I look at this right here, my symbol we call a radical. Okay, so the symbol is called the radical. My number underneath it we call the radicand. Okay, the radicand. And all this is in the top of our lesson on page 7, on top of lesson 18. I'll go back to it in just a minute. Now, one of the things I want you to notice right here is there is nothing written there. Okay, this is the place where my index goes, and if there is nothing written there, I understand that it means a square root, and I understand that a 2 goes there. If they're ever wanting you to do something different, they will put a number there. So sometimes you might see something that looks like this, and that means the cubed root. Okay, so again, if there is not anything here, I understand that to be a number 2. Meaning square root. So you know how, like, when we talk about 2 squared, it's that little exponent of 2. When I do my reverse operation dealing with square roots, it's the same thing. Okay, but because we encounter it more often, or most of the time, we understand that if there's not a sign there, that it means that that index is 2. Okay, so one of the things that when I'm taking a square root of a number, so we'll work with 4 again. What I want to do is, if I did not know my perfect squares, and I didn't know that the square root of 4 was 2, I would break this into prime factors. So just like we just did with greatest common factor and least common multiple, we listed our prime factors. Well, I'm going to do the same thing with dealing with square roots. Okay. Now, one of the things that I have a tendency to do is trying to come up with kind of silly things to help me remember mathematical stuff, okay? And I think that comes from when I would study with my mom when I was growing up. She would always come up with silly things for me to memorize stuff. So there are certain things that I still remember from, like, reviewing flashcards and things with her, where she would come up with silly things, but I remember them still, okay? So I've kind of come up with a silly way to kind of deal with radicals. I want you to know that this is not mathematical, okay? This is just Jennifer Fountain's silly way of remembering how to deal with radicals. So basically, my understood number here is 2, okay? I understand that to be a 2. So these little guys, I call this the house, okay? I call my radical the house, and these little guys are inside the house. And they want to go outside. But Mama said they cannot go outside unless they have a buddy, okay? So this number right here tells me how many buddies they have to be able to go outside. So since this number here is a 2, they need 2 buddies to go outside, okay? So I have circled those 2 buddies, but when they get to go outside, they come outside as one group of 2, okay? So this number tells me how many buddies there have to be. I circle that number of buddies, but when they come outside, it's only as one group of 2. So let's look at that on a number that isn't a perfect square. And let's look at the square root of 8, okay? So the first thing I do is I list my prime factors of 8. If you need to do a factor tree, if you want to do a factor ladder, if you just want to come up with the factors, it's up to you, but I have to list all prime factors. So I know my smallest prime factor is 2, so that's where I always start. So I say, okay, is 8 divisible by 2? Well, yeah, it is because it's even. So I know that 2 will go into 8. 2 will go into 8 4 times. So now I've got to break down the number 4 into prime factors, and I know that that is going to be 2 times 2. Okay, so anytime I've done prime factorization, I can always check to make sure that these numbers multiply together to equal that. And 2 times 2 is 4, and 4 times 2 is 8. So I know that 3 2s is going to equal 8, so I'm good. Now remember, my understood number there is 2. That's called my index. My index is 2, so that means there's got to be 2 buddies for one group to go outside. Okay? So I circle my buddies so they get to go outside. But this poor guy right here, he can't go outside because he doesn't have a buddy. So he has to stay in the house. Okay? So my group of 2's got to come out as one group, but my poor little guy that's by himself and doesn't have a buddy, he has to stay in the house, or he has to stay under the radical. Okay? Let's look at another number. Let's try, let's see what's one that I can do that would be, let's do 12. Okay, let's list our prime factors of 12 first. So I know that's going to be 2 times 6, which is going to be 2 times 3. So I can check and make sure I've gotten my numbers right. 2 times 2 times 3, 2 times 2 is 4, 4 times 3 is 12, so I know I'm good there. I look at my index. There's nothing there, so I understand that it's 2, so that means 2 buddies. These 2 guys get to go outside as a whole group of 2, but poor little number 3 has to stay inside. Let's try the number. I want to do one that shows us, let's see.
5.
Well, 5 is prime, so I can't break it down. I'm trying to think of what would be one that we could leave. How about the number? Let's do the number 36. Okay, so first step, prime factorization. All right, so I know my smallest prime factor is 2. 36 is divisible by 2 because it is even. So I know 2 times 18 is 36. So now I have to break down 18. 18 is also even, so it's divisible by 2, and that's 2 times 9. Okay, 2 times 9, so now I've got to break down 9, which is 3 times 3. Okay, so now I've got all my prime factors. 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. Now, how many buddies do I need to have of each number? 2. I have 2 2s, so they get to go outside. I have 2 3s, so they also get to go outside. So when they go outside, my 2s come out as a 2, my 3s come out as a 3. Now, if I have 2 numbers that come outside, then I have to multiply them together, so 2 times 3 is 6. Okay, and so if we look back at our perfect squares, 6 squared is 36, so that means the square root of 36 equals 6. Okay, so let me go back to the lesson since we've gone through that, and we'll take a look at what it says. Okay, so again, like we just said, the opposite of raising a number to an exponent is taking the root of the number. The root is represented by the symbol, the radical sign, okay? The number under the radical is called the radicand, and the number that indicates the root is called the index. So we've just talked about all of that, okay? So notice here, we're talking about 2 cubed equals 8. So if I wrote that as the cubed root of 8, that would equal 2. Okay, so we're going to kind of practice with going back and forth with a number raised to an exponent versus a square root or a cubed root of a number. It says to find the square root of a number, find a number that when multiplied by itself gives the radicand. So like right here, the square root of 16 is equal to 4 times the square root of 4 times 4. And so those buddies were able to come out as a whole number 4. Now again, in this one, if they had gone ahead and done prime factors, I know that that would be 2 times 2 times 2 times 2. Okay, so we'd have a group of buddies here that gets to come outside as a 2. This group of buddies gets to come outside as a 2, and we multiply them together to get 4. No matter what numbers you break them down, you're still going to end up with the same radical number. Okay? And it says for larger numbers, write the radicand as the product of perfect square factors and find the roots. So it's the kind of thing that if you're not familiar with perfect squares, that's going to be harder to do. Okay, so that's why I showed you how to do prime factorization. That will always work if you can't think of perfect squares. Okay, so like with 128, had they done perfect squares first, you would have 2 times 64. 64 would be 2 times 32. 32 would be 2 times 16. 16 would be 2 times 8. 8 would be 2 times 4, and 4 would be 2 times 2. So we have a whole bunch of 2's here, okay? So again, we'd find our buddies. We got buddies there, buddies there, buddies there. And then this poor little guy, he's all by himself in the house. Mama won't let him go out by himself. So this group of 2's comes out as 1 2. This group of 2's comes out as another 2. This group of 2's comes out as another 2. And there's poor little guy in the house. So then I multiply 2 times 2 times 2 is 8 times the square root of 2. So that's how you would do it if you broke it into prime factors. You just circle your buddies, bring it out, the whole group, and then whatever's left has to stay in the house, okay? I know it's kind of a silly way to do it, but like I said, it's just something, you know, when I talk about how many buddies can go outside and stuff like that. All right, so the next thing we're going to look at here, I'm going to erase this so we can see our words. So the next thing we look at is going to be adding and subtracting roots. So it says to add or subtract roots, the radicands and the indexes must be equal. Okay, remember the radicand is the number underneath the radical, and the index is that little bitty number that is outside the sign. And if it's nothing there, I understand it's a 2. Okay? So the example they've given us is the square root of 3 plus the square root of 3. All right. And it says if there is no number, treat it as a 1. So if we look in front of that square root of 3, I do not have a number here, so I'm going to act like I've got a 1 there, because like when my understood number in front of a radical would be 1 times the square root of 3. And so it says here, you add the numbers immediately to the left of the radical. If there is no number, treat it like a 1. So here, when I add 1 times the square root of 3 plus 1 times the square root of 3, I add 1 plus 1 and get 2, and then I just leave the radical the same. Okay? As long as the radicals are the same, I keep my radical in my answer, but just add the numbers that are in front of the radical. So now if we look at this one, I've got 2 times the square root of 5 plus 4 times the square root of 5. So you just add 2 plus 4 is 6. And then you're just leaving, since these are the same, it all stays the same. Okay, so your radical stays the same. Just add the numbers in front of them. And it says if the radicands or the indexes are not equal, the roots cannot be added or subtracted. Okay, so they have to be the same to be able to add or subtract. Now the next section says to multiply or divide roots with the same index. The only thing has to have is the same index. You multiply or divide the radicands and write the answer under one radical. Okay, multiply or divide the numbers outside the radical and write outside the radical in the answer. So let's take a look at this one. If they have the square root of 12 times the square root of 3, they went ahead and put it underneath one sign. They took them from being separate and put them together under one sign. Well, 12 times 3 is 36. And that's a perfect square. I know that the square root of 36 is going to be 6. If I did not know the square root of 36, I could break it into prime factors and say that's 2 times 18, which is 2 times 9. 9 is 3 times 3. I circle my buddies. My 2 comes out as a whole number 2. My 3 comes out as a whole number 3, and I multiply them together. So if you did not know 36 was a perfect square, then I could always go with simplifying based on my prime factors. Okay, so we're going to practice with this because I know this is a lot to take in. All righty. So what we want to look at here is it says to rewrite the following expression as roots. Okay. So basically, when I'm looking at 3 squared equals 9, and I want to look at it as a radical, what I do is I'm going to put my 9 under the radical. My little exponent is what my index is, and my number, this number is 3. So this exponent comes here, 9 goes there, and my 3 goes outside. So this shows that the square root of 9 is 3. Now when I look at 4 cubed equals 64, again, my big number here becomes my radicand. My little number here, 3, is my index, so it's going to go there. And then that is going to equal 4. The next one, I have 2 to the 4th power equals 16. So if I was going to express that as a radical or as a root, I would have my square root sign. 16 goes under here. Now my exponent of 4 is going to go out here as my index. My exponent becomes my index. And so that is equal to 2. And the reason for that Same thing. If I have my index of 4 right there, and I broke 16 into prime factors, that's 2 times 2 times 2 times 2. Remember how that index tells me how many buddies I have to have? And in this one, I have to have 4 buddies for one group to come outside. Okay, so that's that. The index is important because it tells me how many buddies have to be put together to come out as one whole group. All right, so again, 5 squared equals 25. So that means the square root of 25 equals 5. 5 to the 3rd power, or you could also call that 5 cubed. That's going to be the cubed root of 125 equals 5, because 5 times 5 times 5 equals 25. I'm sorry, equals 125. Okay, so this just kind of shows us how our numbers with exponents are the opposite of our radicals, or taking roots, okay? So depending on what the exponent is, determines if it's a square root, a cubed root, which is what we call with the 3, that's when a cubed root, or a 4th root, or whatever, okay? So let's go ahead and look at our examples. So it says to solve the following roots. This first one, I know that 16 is a perfect square. So I know that the square root of 16 is 4, but if I did not know that, I would have to start out by prime factors and do it and working with my buddies, which is 2 times 2 times 2 times 2. Okay, my index here is 2, so I need 2 buddies to come outside, so I circle 2 buddies. That one comes out as a whole number, that one comes out as a whole number, and 2 times 2 is 4. Is what I'm saying making sense? Are y'all following, or are y'all lost? Are y'all okay? Okay, just be sure to let me know if what I'm saying is not making sense. Let me know so I can find another way to try to describe it, okay? The next one is the cubed root of 27, okay? So that means I'm gonna rewrite this with my index of 3, and I've gotta show my prime factorization of 27. It's not even, so I know it's not divisible by 2. So I'm going to try 3 next. My rules of divisibility tell me that if I add 2 and 7 and that equals 9, 9 is divisible by 3, so 27 is divisible by 3. And I know that 3 times 9 is 27. So now I need to break 9 down into prime factors, so that's going to be 3 times 3. All right, I look at my index. Let me change that color real quick. All right, I look at that index right there, and that index is 3. So that tells me I have to have 3 buddies to go outside. So I circle 3 3s. So it comes out as one group of 3. There's nothing left under the radical, so it just goes away. If there's a number left, it has to stay under it. The square root of 32. I know it's divisible by 2 because it's even, and that's going to be 2 times 16. Well, we already broke down 16 a minute ago, so we know that's 2 times 2 times 2 times 2. Got a whole bunch of 2's. All right. Mama said we have to have buddies. We've got to have 2 buddies to go outside. So here's a group of buddies, and here's a group of buddies, and there's that poor little guy that has to stay inside. So this 2 comes out as a whole number 2. This 2 comes out as a whole number 2. And this little guy has to stay under the radical. So when I multiply those together, I end up with 4 times the square root of 2. Okay. Now we have the cubed root of 16. So 16, we've already broken it down several times. That's 2 times 2 times 2 times 2. Okay. Now my index is 3. So Mama said there has to be 3 buddies to go outside. So I circle 3 2's so they get to go outside as a whole group. But then this poor little guy has to stay inside. And remember that when it's a cubed root, I have to write that index of 3 there. Okay. All right, now we're going to start adding. And remember, if there is not a number in front of my radical, I treat it as a 1. So I go ahead and write 1s in front of those square roots of 2. Remember, my rule is that my number underneath the radical, which is called the radicands have to be the same. And the indexes, that tiny little number outside, has to be the same. So since there's nothing there, I understand both of my indexes are 2s. Both of my radicands are 2s. So I'm good to add. So all I do is I add my first number. 1 plus 1 is 2. And I keep my radical the same. Okay, so let's look at the next one. If I understand that this one is 1, both of them are dealing with the square root of 5, so my index and radical is the same. So 1 plus 2 is 3, and I keep the square root of 5. Same thing with the next one. My radicand is 10. My index on both of them is 3. So my indexes and radicands are the same. I know this is to be a 1 since there's nothing there. So 1 plus 5 is 6. And then the cubed root of 10 stays the same. Same thing when I subtract. As long as my index and my radicand is the same, all I do is subtract my first two numbers. So 6 minus 4 is 2, and I keep my radical the same. In the next one, I have the cubed root of 5 for both of them, so those match. So 5 minus 4 is 1 times the cubed root of 5. So I could just write that as just the cubed root of 5. You could either leave the 1 there or take it off. It doesn't matter, because you know that anything times 1 is itself. All righty. Multiplying. Remember, we talked about how when I have two things I'm multiplying together, I can put them under the same radicand, or my same radical sign. And that's going to be 10 times 2 that I'm putting underneath the radical together. Now, one of the things that I always have to check on, I always have to make sure that I have reduced my radicand into simplest form. Okay, and so what I want to do is, if I see that I'm going to get a bigger number, I want to go ahead and list it as prime factors so I can go ahead and simplify this. Okay, so I want to break 10 into prime factors. My smallest prime factor of 10 is going to be 2, and that's going to be 2 times 5, right? So 2 times 5 is 10, but I already have this guy here, so I have to make sure to list him as well. Okay, so now I've broken that into prime factors, and I look at my index. Index is 2. So Mama said there have to be 2 buddies, and oh look, there's 2 2s right there. So those 2 2s get to come outside as a whole number 2, and then poor number 5 has to stay in the house. Okay, since I went ahead and broke that down, it made it easier to go ahead and simplify into simplest form of a radical. I could have multiplied that together and said it was 20. And then I could have found the prime factorization of 20. But I'd rather find the prime factorization of 10 than 20. It's gonna be faster and easier. So I like to go ahead and break them down before I multiply together. Okay, so let's look at the next one. Okay, so remember, if I have numbers on the outside, I go ahead and multiply those first. So 3 times 2 is 6. So multiply your whole numbers together. Then we'll put your numbers under the radical. So then I have 5 times 2 under the radical. 5 is a prime number and 2 is a prime number. So I know that I cannot simplify that at all. So I go ahead and multiply them together for my final answer. So my final answer is 6 times the square root of 10. Does everybody see how I did that? I just multiplied those first numbers first, the numbers in front of the radical sign, 3 times 2, and that was 6. Then when I combined the square root of 5 and the square root of 2 under the same radical sign, I know that 2 and 5 are prime factors. So I just went ahead and multiplied those together. All right. The next one, I have the square root of 27 divided by the square root of 3. So again, I can combine these under the same radical sign and have 27 divided by 3 under the same radical. So 27 divided by 3 is 9. So now I have to look and say, okay, is that in prime factor form? 9 is not a prime number, so I know I need to break it down. And I know that 9 is 3 times 3. I look at my little number outside, my index. It is a 2, so Mama said 2 buddies. So those 2 buddies get to come out as a whole number 3. So my answer is 3. This one, index and radical. Let's go ahead, and so I'm gonna divide 10 divided by 5 first. 10 divided by 5 is 2. Then I've got the cubed root of 16 divided by the cubed root of 4. So I go ahead and combine those under the radical together. Okay, I know that 16 divided by 4 is 4. So I have 2 times the cubed root of 4. Now if I broke down 4, that's just going to be 2 times 2. My index is 3, so I know I have to have 3 buddies to come outside. Since I would only have 2 underneath that radical, I don't have to break it down. That is going to be my final answer. Okay. Now the last one that I want to show you. I have a whole number divided by a radical. And remember that my rule for multiplying and dividing roots was they have to have the same index. Okay? So a whole number 3 doesn't have an index, does it? So what I've got to do is I've got to turn this one into a radical. So I want to turn into a radical. All right. So what I have to do is I have to think about, if I want to turn it into a square root, then that's the opposite of having 3 squared. Okay. So remember up here, when we looked at this part right here, and we said 3 squared equals 9, so the square root of 9 is 3. If I'm turning the whole number 3 into a radical, then I'm going to take 3, I'm going to multiply it by itself and put it under the radical sign. So the whole number 3 becomes the square root of 9. So now I have the square root of 9 divided by the square root of 3. I can put those under the same radical sign and have 9 divided by 3. And 9 divided by 3 is 3. So basically, anytime I have a whole number divided by a radical, and it's the same number under the radical as the whole number, my answer is just going to be that as a radical. So just like if I had 7 divided by the square root of 7, my answer would be the square root of 7. If I had 5 divided by the square root of 5, my answer would be the square root of 5. Because here, the square root of 3 times the square root of 3 equals the square root of 9, which equals 3. The square root of 7 times the square root of 7 equals the square root of 49, which equals 7. Okay, so all you've got to do is tell what the radical answer would be. So let's work some of this practice together so we can kind of, you guys can ask questions that you're not quite answering, I mean, or quite not understanding on your own. So what I want you to do first is let's go ahead and do activities 2. We want to rewrite these as roots. Okay, so we're going to look back at the first part of our classwork. Look at what we did. We saw that our base number became our answer. Our exponent becomes our index. And the number on the right-hand side of the equal sign becomes our radicand. Okay, so go ahead and work these in activities 2. And as soon as you finish those, it's time for our break. We're actually a couple of minutes over break time, so we will take a 5-minute break and then come back and go over the answers. So after you've finished them, you can take a break and then we'll come back. All righty. We will go ahead and take a look at those where you rewrote the following expressions as roots. All right, so the first one was 2 to the 5th power equals 32. How am I going to write this as a root? I'm going to write my radical. I'm going to draw my symbol. And then what number is going to go underneath my radical? What is going to be my radicand?
32.
32. Good. What is going to be my index? What is going to be my little bitty number that sits on top of my symbol? 5. Good. So the 5 goes there. And so then that is going to equal to 2, because I'd have to multiply 2 by itself 5 times to equal 32. Okay? So that's what that's telling me, is that I multiply 2 by itself 5 times, and that equals 32. So the 5th root of 32 is 2. Let's look at 4 squared equals 16. I'm going to draw my radical. What number goes underneath the radical? What is my radicand? That's going to be 16, right? My understood index, it's a 2. If you want to write it there, go ahead and write it there. It is just fine. Equals 4. So the square root of 14 is 4, because 4 times itself 2 times. 4 times 4 is 16. Okay? Let's look at the next ones. I have 3 to the 3rd power equals 27. I draw my radical. 27 is my radicand. My index, or my little number, is going to be 3. And my answer is also 3, because 3 to the 3rd power is 27. 3 times 3 times 3 is 27. So the 3rd root of 27 equals 3. My next one is 7 squared equals 49. So 49 goes under the radical. That's the radicand. My exponent of 2 becomes my index. So my square root of 49 is 7, because 7 squared is 49. And then the last ones. 5 to the 4th power is 625. That means if I multiply 5 by itself 4 times, 5 times 5 times 5 times 5, that equals 625. So under my radical, I have 625. My index is 4, and that equals 5, because 5 to the 4th power equals 625. So the 4th root of 625 is 5. And finally, 6 squared is 36. So 36 goes under here. 2 becomes my index, and that is 6, because 6 times 6 is 36. So the square root of 36 equals 6. How did y'all do on those? Y'all do okay? Awesome. Very good. Let's go ahead and work on solving roots. Okay? I want you to work on these right now, and I want you to let me know if you have questions. Okay, so we're going to work on activities 3 right now, working on just solving the roots, adding, multiplying, subtracting, and dividing. Okay, I want you to be able to ask me questions if you get stuck on something. So we'll take a little bit of time and work on these. So let me know if you need help. No. 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 Stop barking. Shh.
I need help.
All right, which one?
With the 6 times 3.
Okay. So remember when I multiply, I can put those underneath the same radical and have 6 times 3. But what I want to do is I want to go ahead and break the 6. Since it's not prime, I want to go ahead and put it in prime factorization. So what are the prime factors of 6?
2
2 times
and
what?
3.
Good. 2 times
3.
3. I already had a 3 right there to begin with, right? So we have 2 times 3, which was 6, and then we also have the 3. So now, how many do I need to circle to make a buddy group?
2.
2. So I get to circle those 2. So they come out as a whole number 3. And then what's left under the radical?
2.
Very good.
Thank you.
You're welcome.
The one under it, I think I might have gotten right, but I'm not really sure. Could you help with that one?
Okay.
Tough.
All right. So we know that we have the whole number 3. And we know that there would be a 1 in front of the square root of 2. And 3 times 1 is just 3. So my 3 is going to go there. Then I'm going to go ahead and draw my radical. I'm going to put my first 2 underneath it. And then I'm going to be breaking down 12. Okay, so I want to go ahead and break down 12, or actually we'll go ahead and write it and then we'll redo it. So let's do this. Okay, so I've got my whole number 3. I've got that 2, but now I need to break down 12. 12 will be 2 times 6, and 6 will be 2 times 3. Okay, so now how many buddies do I need for a whole number to come out? I need 2 buddies. Okay, so I'm going to circle 2 2s. So that's all that's going to be able to come out because I have a 2 and a 3 left. Okay, so I already had this 3 that was in front of my radical. So I have my 3. My group of 2s comes out. So I'm going to multiply those together. Then under my radical, I still have left 2 times 3. So what I'm going to do is I can multiply these together. 3 times 2 is 6. And then under my radical, I can multiply 2 times 3, and that is 6 as well. Okay, y'all ready to go over these? All right, so let's go ahead and take a look. All right, so the square root of 25 is equal to 5. Okay, the square root of 9 is equal to 3. Those are perfect squares. Again, if you didn't know they were perfect squares, you could list out the prime factors and get that. The square root of 8 is going to end up being 2 times the square root of 2. All right. The square root of 12 will end up being 2 times the square root of 3. Any questions on those? Everybody do okay? All right. The cubed root of 27 is 3. And then the cubed root of 64 is 4. Any questions on those? Everybody do okay? All right. Then when we're adding the square root of 7 plus the square root, plus 3 times the square root of 7, I need to put a 1 in front of the square root of 7, so that becomes 4 times the square root of 7. I'm going to move on up to the other side. I'll erase that little arrow right there. And 8 times the cubed root of 11 minus 5 times the cubed root of 11. 8 minus 5 is 3 times the cubed root of 11. And then we walked through the square root of 6 times the square root of 3, and we found where we would multiply those together or we would look at the prime factors, find our buddies, and we found that that was 3 times the square root of 2. Then we also did the square root of 2 times 3 times the square root of 12. We found where we would break those into prime factors. We already had a 3 on the outside, so we multiplied that by the 2 that we were able to pull out. And then we had a 3 and a 2 left under the radical, so our answer there was 6 times the square root of 6. Then 50 divided by the square root of 2 ends up leaving us with the square root of 25, but then that could be simplified, and the square root of 25 is 5. Okay, so remember to simplify if you can. 4 times the square root of 18 divided by 2 times the square root of 6. 4 divided by 2 is 2. And then under the radical, I'd have 18 divided by 6. And 18 divided by 6 is 3. So I have 2 times the square root of 3. And then 5 divided by the square root of 5 is the square root of 5. How'd y'all do? Any questions? Did y'all do okay? Awesome. Very good. Very good. Okay, so let's see. It is 2:02. Let's see. Let's go ahead and move on to lesson 19. We are not going to do any more on page 40. Okay, so you won't have any homework on page 40. Let's go ahead and look at lesson 19, writing expressions with one variable. Okay, so you may or may not know that when we use letters in math, we call those variables. And it says a variable is a letter used to represent an unknown numerical value. So a lot of times in algebra, we use the letter X. Okay, that's the most common variable. You can pick any variable you want to. You can use N, you can use X, you can use S or T or whatever you want to use to express a variable, but the most common that we see is X. So it says in an expression or equation, a letter in more than one location always represents the same amount. So if I had like 2x plus 7 equals x plus whatever, I know that everywhere I see x, that when I solve it, x is going to be the same amount every single time. Okay, so if I have a problem that has two different variables, I know that they represent two different amounts. So if I see the same variable in a problem, then I know that it's going to be representing the same amount, but if I have two different variables, that represents two different amounts. Okay, so it says to write expressions with a variable, let x represent the unknown amount. And it says to use the following rules to translate words into numeric expressions. So what we're going to be working on is we're going to have some words that we have to translate into numbers and symbols based on addition, subtraction, multiplication, and division. So our words for addition, whenever we see more than, total, sum, increased by, added to, or together, I know that I'm dealing with addition. And so when I see those words, I am going to use a plus sign. Okay. So for subtraction, I know that I'm going to see less than, fewer than, difference, decreased by, or reduced by. So anytime I see those in one of my expressions, I'm going to use a minus sign or a subtraction sign. For multiplication, anytime I see times, of, multiplied by, product, or increased by a factor of. Notice that addition says increased by, but multiplication says increased by a factor of. Okay, so that's the difference between those two. But when I see that, I'm going to use my times sign. Now, one thing to notice is that we can use a times sign, we can use parentheses, we can use a dot. Those are all indicating multiplication. Okay. And then finally, division, I'm going to see the word per, the word a, ratio, quotient, percent, or out of. And remember, with division, I can use a division sign, or I can represent it as a fraction, okay, where I have my numerator and my denominator. So the number I'm dividing into is in the top, and the number I'm dividing by goes on the bottom when I represent it as a fraction. When simplifying expressions, combine like terms. Like terms have identical variables with identical exponents, or they're constants. And constants are numbers that have no variables, okay? And it says constants are like terms and can be combined using the order of operations. Variable that are like terms that may be combined by following the order of operations. So we're going to look at what this is talking about here. All right, so we're going to translate the following words into a mathematical expression. 5 more than a number. So I see more than right here. What operation does that indicate? Addition, good. So I know that I'm going to be adding 5 plus, and then remember, we're going to use a variable to represent a number. You can either use the letter N for number, or you can use the letter X. Like they said, the most common one is X. So basically, I have 5 plus X. Now remember, addition and multiplication are commutative. So remember, that means it doesn't matter what order. So in this one, I could either have 5 plus X, or I could have X plus 5. Both of them are going to be the same. What does matter is subtraction. So we have to pay close attention to that. So let's look at this next one, 3 less than a number. Okay, so I know the number 3. Less than indicates what operation? Subtraction. And then we can use X for our number. But what I have to think about here is which one comes first. If I say 3 less than a number, that means my number comes first, and then I'm taking away 3. Okay, so that means I'm going to have X minus 3. So with subtraction and division, I have to be super careful with my order. With addition and multiplication, it doesn't matter. All right, let's look at the next one. I have a number increased by a factor of 4. So increased by a factor of 4. All right, this is where it gets a little tricky using our x for a time sign and an x for a variable, because if I said this was x times a factor of 4, then I've got x times 4. And that looks funny, doesn't it? That is kind of confusing. So whenever I'm dealing with the variable x, I don't want to use an x for my time sign, okay? So what I want to do here is I can do one of two things. I can either write my number 4 with the variable x, and when I write a number next to a letter, I understand that means multiplication. Okay, so when you have a number next to a letter, that indicates multiplication. So I could either do that, or I could do 4 times x, or x times 4, or I could use parentheses. Okay, so I can either write it just side by side, I can use a dot to indicate multiplication, or I can use those parentheses. Okay, the main thing is if I'm using a variable x, I just don't want to use an x as a time sign. All right, the next one is a number increased by 7. What does increased by? What operation am I going to use? It's going to be addition, right? So I've got my number that we can use as x increased by 7. So x plus 7. Then the next one is 6 decreased by a number. So this is where I have to think about, okay, which number comes first and what is being taken away from it? So in this one, 6 decreased by a number means I'm going to have 6 minus x. And then a number multiplied by 2. So again, if I'm using x as my variable, I know that I'm going to be using multiplication, but I don't want to have x2. So I can write this as 2x. I could write it as 2 times x in parentheses. I could write it as 2 with a dot and x, but typically when I write a number and a variable, I write the number first. Okay, so typically I'm going to see my number and then my variable. Any questions on those? Any of those that you were confused by? Awesome. Let's go ahead and look at the next part. This is simplify by combining like terms. Now remember, we said that if I have a variable and another variable, as long as they're the same, I can combine them. So do you remember a little bit ago when we were adding our radicals and we said that if there was nothing in front of our radical, we understood it to be a 1? I'm going to do the same thing here. If I have no number in front of my variable, I understand that to be 1. So now when I add 1 plus 1 is 2, and I keep my variable of x. Okay. On this next one, my like terms are going to be 2 plus 3. So that's going to be 5 plus x. There's nothing else I can add to x. All right, on this one, I have 2x plus x. Remember, I understand that I have a 1 in front of that x. So 2x plus 1x is 3x. And then I have 4 plus 1 is 5. So 2x plus x plus 4 plus 1 becomes 3x plus 5. So let's go ahead and take a look at these examples. All right, the total of a number and 45. So what am I going to use for the total of? I'm going to be adding, right? So I'm going to add a number and 45. So x plus 45. 9 fewer than a number. Fewer than is my keyword. I understand that it is subtraction. So now I have to really think about what comes first. 9 fewer than a number. If I see more than, fewer than, less than, greater than, whatever, if I see that, then I know whatever comes after than is what needs to come first in my problem. Okay, so my key there is the word than. So that means my number is going to come first, then I'm going to have my sign, and then my 9. Okay, so if it's fewer than, less than, more than, whatever, I know that that's my, whatever comes after than is going to be first. A number times 8. So I'm going to subtract. Good grief. I'm going to multiply. And so remember, we said that we could just write a number and a letter side by side, and that means multiplication. And I'm going to write my number first. When I have a number with a variable, we call that a coefficient. When I have a number by itself, we just call it a constant. All right, the sum of 29 and a number. So we know sum of means I'm going to add. So I am going to add 29 plus a number, x. The quotient of a number and 9. The word quotient, what operation am I going to deal with there? Quotient is division. Okay, so on this one, the quotient of a number and 9. With my division, whatever comes first is first in my problem. So I would have x divided by 9, or if I wanted to write that as a fraction, I would have x in my numerator divided by 9. Okay, both of those indicate division. The next one is 7 less than a number. Remember, we talked about if it says than, my number is going to come first, or whatever comes after than. So that's going to be x minus 7. A number increased by a factor of. Okay, remember that indicates multiplication. So if I'm multiplying the variable x and 3, I would just write that as 3x. 43 more than a number. So on this one, you could follow the same rules that we were talking about where it says 43 more than a number. So our number would come first and then add 43. But again, it doesn't matter if it's 43 plus x or x plus 43. Commutative property tells me that order doesn't matter for addition and multiplication. But it does for subtraction, which is next, less than, a number less than 83. So we know 83 is going to have to come first, and then we subtract our number x. The product of 2 and a number. So the product of, what operation is that going to be? We know a product is an answer in multiplication. So the product of 2 and a number, so I'm going to have 2 times my number. The ratio of, all right. When you hear the word ratio, I want you to go ahead and start picturing a fraction. The word ratio and fraction can be used. A ratio is comparing two numbers, and so we can use that in fraction form if we want to. So this is a ratio. So we know that a fraction is the same as, or is division. So we know what operation that is. I'll move that so we can see it a little bit better. There we go. The ratio of a number to 10. So that means my number is first. So I'd have either x divided by 10 or x over 10, either way. And then finally, a number increased by. Increased by tells me I'm going to add. So I have my number, x plus 23. Does everybody feel pretty comfortable with these? Feel pretty comfortable knowing what to write where? Awesome. All righty. Now what I want to do is go ahead and work on activities 3. We've only got about 5 or 6 more minutes left. I want us to go ahead and practice on combining like terms together. Okay. So in activities 3, I have x plus 5 plus 3. I don't have any other common term to combine with x, so he's just going to stay by himself, plus, but I can combine 5 plus 3, and 5 plus 3 is 8. So that's as simplified as I can get it. Since I do not know what number x is, I just have to leave it as a variable. Okay? So now in this one, I have x plus x. Those are like terms. And we've talked about how if there is not a number, if it does not have a coefficient in front of it, I understand that number is 1. So I'm going to go ahead and write a 1 in front of my x. So I have 1x plus 1x. So 1x plus 1x is 2x. And then I have 4 plus 8, which is 12. Now I want you to go ahead and work on the last 4. Go ahead and do the last 4, but if you have questions, let me know. Okay. All righty, so let's go ahead and take a look at these. I have 2x plus x is going to give me 3x. And then I have a positive 7 minus 2. So 7 minus 2 is a positive 5. Then 3x plus 2x is 5x. Then I have a negative 8 plus 3. So negative 8 plus 3 will be negative 5. So I have minus 5. Okay. 4x minus 2x is going to be 2x. Then I have 10 minus 5 minus 3. So a positive 10 minus 5 is going to give me a positive 5. And then positive 5 minus 3 is positive 2. So it will be plus 2.
Wait. 8 plus 3 is not 5.
Okay, so look at this.
No, at the not the bottom one, but not the one.
Okay,
the
talking
third
about
one.
right here.
Yeah.
Okay, that is a -8. So since the minus sign is in front of it, remember if I'm subtracting or if I have a negative sign, or you could have,
Sorry, mistake.
yeah, so in this situation, we have to treat that as a -8. Okay. So then, same thing here. We've got 10 minus 5 is 5, and 5 minus 3 is 2. Then here, I have 4x plus 3x minus x. So 4x plus 3x is going to be 7x, and 7x minus x will be 6x. Okay? And then I have -4 minus 3 plus 2. Okay, so what I've got to do here is I've got, I have got -4 minus 3. So -4 minus 3 is the same as saying -4 plus a -3. So that's -7 plus 2. Okay, so -7 plus 2 is a -5. So I'm going to have 6x minus 5. Okay, how'd you do? Y'all do okay? The main thing is understanding what a like term is, and then the other part of it is working with those positives and negatives. Okay, so making sure that you're doing okay with those. All right, so our homework will be, I want you to work on activities 5 on this page. Okay, so that's all your homework is going to be, will be activities 5 on page, what page is that? Page 42. Okay, so page 42, activities 5, working with your radicals. If you have questions, be sure to let me know. If not, then we will go over these and check them on Monday. So we will be back at the co-op on Monday. So I look forward to seeing y'all then. Okay. All right. Y'all have a great weekend, and I'll see y'all next week. Bye-bye.
Yeah.
Thank you.